Buckle up, because the Tesla Cybertruck is rewriting the rules of electric vehicles, and we've got the inside scoop on its mind-blowing battery tech. Recently published EPA documents regarding the Tesla Cybertruck have revealed key information like the pack's voltage capacity and energy density. In this video, we'll explore how Tesla's second-generation 4680 battery cells and structural pack have improved since the first generation. Plus, we'll explain how the Cybertruck's unique 800-volt architecture enables it to charge even on a 400-volt charger. So, let's dive into the exciting details right away. The Tesla Cybertruck is packed with some serious technological firepower, starting with its second-generation 4680 battery cells, which are a whopping 10% more energy dense than the first generation. But that's not all. This electric beast also boasts a second-generation structural battery pack design. At Tesla's Battery Day event, they promised this structural battery pack would enhance range significantly. The idea was to combine the benefits of the 4680 batteries, the structural battery pack, and underbody castings for a remarkable 10% reduction in mass and a 14% range boost. However, it's crucial to note that Tesla's first attempt with the Model Y, equipped with first-gen 4680 batteries and a structural battery pack, didn't quite meet those expectations. It suffered from lower-than-expected energy density in the battery cells and an arguably less optimized structural battery pack. But here's where the excitement builds up. The Cybertruck takes things to the next level with a second-generation version of both the structural battery pack and the 4680 batteries. Remember the 18650 cells used in the Model S and X and the 2170 battery cells used in the Model 3 and Model Y? Well, they had a higher cell-level energy density than the first-gen 4680 cells. Now, when it comes to pack-level energy density, which is pretty crucial, the first-gen structural battery pack, used in the Model Y, didn't fare as well as its counterparts with 2170 battery cells. It had an estimated energy density of around 158 watt-hours per kilogram, significantly lower. But here's the game-changer. With the second-generation design featured in the Cybertruck, Tesla's new 4680 battery cells are a whopping 10% more energy dense than the previous generation. This could mean that the cell-level energy density of the second-gen 4680 battery cells is even higher than that of the 2170 cells used in the Model Y. Now, let's talk about pack-level energy density, which is the ultimate measure of an electric vehicle's efficiency. Recent EPA documents have disclosed that the Cybertruck's battery pack boasts an energy density of 170 watt-hours per kilogram. While this is an improvement over the first-gen battery pack, it's still slightly lower than the pack equipped with 2170 cells. This is a big deal because it suggests that even with the next-gen structural battery pack found in the Cybertruck, Tesla hasn't fully optimized it to match the energy density of the packs with 2170 cells. Now, it's possible that there's more to this story that we haven't quite figured out yet. You see, the Cybertruck's battery pack serves a dual purpose. It's not just about providing power, but it's also part of the truck's structural integrity. So, while the pack-level energy density may seem slightly less than that of the 2170 or 18650 Tesla battery packs, there's a twist to this tale. It's conceivable that this new technology might offer the same equivalent in terms of pack-level energy density, but we might need to coin a new term for this. Something like pack-level energy density equivalency. Calculate this more accurately. The truth is, we might need to wait for more data from Tesla or independent experts who dissect the vehicle to truly understand this concept. But even with Tesla's second-generation structural battery pack design in the Cybertruck, it seems like they haven't fully realized all the weight-saving benefits they talked about during Battery Day. Moving beyond energy density, let's talk about battery pack capacity. It seems that the previously reported 123 kilowatt house capacity for the Cybertruck's battery pack is spot on. How do we know? Well, some smart folks over at Tesla crunched the numbers using the 150 amp-hour capacity from the EPA document and came out with 22.4 kilowatt hours for the battery pack size. Now, while the Cybertruck already offers a decent range, up to 340 miles for the most efficient version, reaching that coveted 500-mile mark in the future might require a bit more ingenuity. Tesla might need to consider a range extender or possibly a double-stack battery pack configuration. Without some extra battery layers or a range extender, hitting the 500-plus mile range seems quite challenging. For instance, if Tesla boosted the pack-level energy density by 10%, it could give us around 374 miles of range for the most efficient all-wheel drive Cybertruck version. It's impressive, but still shy of that 500-mile mark. Even if we cranked up the energy density of the Cybertruck's battery pack by another 10%, pushing it over 148 kilowatt-hours, making it the most efficient version of the Cybertruck, would likely have an estimated range of around 411 miles. Impressive, no doubt, but still short of that magical 500-mile mark. Achieving a 500-plus mile range for the Cybertruck is indeed possible, but it's likely going to require the addition of a range extender or some other innovative engineering solutions. Now let's talk about what makes the Cybertruck's charging capabilities even more exciting. It's the first Tesla vehicle to feature an 800-volt architecture. This high-voltage setup allows the Cybertruck to charge at lightning speed. According to Tesla's VP of Vehicle Engineering, Lars Moravi, this electric beast can charge at a blazing 350 kilowatts when connected to a Tesla Vive 4 supercharger. In practical terms, this means you can go from a 15% to 85% state of charge in a mere 18 to 20 minutes. An astonishing feat. However, here's the twist. Most electric vehicle chargers out there, including Tesla's own V3 and V2 superchargers, are designed for vehicles with a 400-volt architecture. So there's a bit of a compatibility challenge here. But the good news is that the Cybertruck has a clever workaround. As Drew Baglino explained in an X.com post, the pack splits into two to charge natively on existing 400-volt charging infrastructure. No costly booster required. Essentially, when you connect the Cybertruck to a Tesla Vive 3 supercharger, the battery pack magically divides into two 400-volt sections. This nifty trick eliminates the need for a DC to DC converter to bump up the voltage for charging. Interestingly, GMC's Hummer EV uses a similar technology, but in reverse. In this case, most traditional EV battery packs operate at 400 volts, allowing them to fast charge at up to 250 kilowatts. However, the Hummer EV takes a unique approach with its two 400-volt battery packs. These packs can essentially be connected in series to emulate an 800-volt system during charging. This innovation enables 350 kilowatts chargers to add 100 miles of range in just 10 minutes. It's a clever workaround that allows for lightning-fast charging. Now, while both Tesla and GMC have found effective solutions for accommodating both 400-volt and 800-volt charging, some other manufacturers, like Lucid and Porsche, have encountered challenges in this regard. For instance, the Lucid Air, with its native 900-plus volt architecture, faces limitations when connected to a Tesla supercharger, designed for 400-volt vehicles. It can only receive around 49 kilowatts while charging, a significant drop compared to the typical max charge rate of around 300 kilowatts. Porsche's Taycan has its own set of challenges. To make use of 400-volt chargers at up to 150 kilowatts, buyers can opt for the optional onboard DC charger package, costing an extra $460. However, without this converter, the Taycan can only charge at around 50 kilowatts when connected to a 400-volt charger. That's a drastic difference in charging speed. One intriguing point to note is the potential energy loss when converting from 400 volts to 800 volts. Drew Baglino's statement about no costly or lossy booster required suggests that boosting the voltage might result in a significant energy loss. Tesla appears to have tackled this issue effectively, eliminating the need for any energy-draining booster when charging at a 400-volt charger. As more information becomes available in the future about the Tesla Cybertruck's battery pack, we'll gain even deeper insights into these groundbreaking technologies. The evolution of electric vehicle charging is an exciting journey, and it's fantastic to see how manufacturers are pushing the boundaries to make charging faster and more efficient. Stay tuned for more electrifying updates. So, what are your thoughts on the Cybertruck's features and the innovative 800-volt charging system? Share with us in the comments below. And if you enjoyed this video, show us some love by hitting that like button and leaving a comment down below. Also, if you're a fan of all things technology, be sure to check out this other video we've got lined up for you. It's packed with all the latest news, tips, and tricks to keep you ahead of the curve.